Hello and welcome to episode 2. Today we're going to do some stoichiometry, which is very basic, but you definitely need to know for later in your chemistry career. Today we're going to be using a reaction with aluminum combining with hydrochloric acid. So for stoichiometry, you have to understand that before you can do anything, you have to make sure that the atoms are equal on both sides. So the reaction has been balanced. In this case, it has been. You have 2 aluminum on each side. You have 6 hydrogen on each side. And then you have 6 chlorine on both sides. So you're either given moles or grams or atoms, and the goal of stoichiometry is to find, using mole ratios, the other moles or grams of another species in that reaction. All right, so let's start off. If you were given moles, let's say you have 87 moles of aluminum, and you're asked to find the hydrochloric, or how many moles of hydrochloric acid from 0.87 moles of aluminum. So for this, you have to have to have an understanding of mole ratio. So this is where you're only going to look at the coefficients. You're not looking at subscripts or anything like that. So we're going to go over here, and we see that the aluminum has a coefficient of 2. And then what we're looking for, our hydrochloric acid has a coefficient of 6. So let me just draw that. We're going from here to that hydrochloric acid. And so something you kind of want to burn into your brain is that learning is going to be your top priority. This is going to be with any dimensional analysis problem or converting. What you're trying to find, it's always going to be in the numerator position. So if we're going to go from aluminum to hydrochloric acid, we have our 87 moles of aluminum. Draw our little picket fence. And so now we're going from aluminum to hydrochloric acid. So learning is our top priority. The thing we're trying to find, the thing we're trying to learn about is our hydrochloric acid. So we're putting that coefficient on the top. Draw that in there. And then we're going to put our coefficient for our aluminum on the bottom. So now, because these cancel out, you're just going to get 2.6 moles of hydrochloric acid. All right, so it doesn't just have to be that. Let me erase the board. So let's say you were trying to find maybe the hydrogen gas. You're still going to use the same thing. We have our 0.87 moles of our aluminum. So that's our initial amount. Draw our picket fence. Excuse my handwriting. So learning is our top priority. So the thing we want to find or learn about is going to be in our numerator position. So our hydrogen gas we're going to find, we're going to put that coefficient on the top. So put our 3 moles. And then put our coefficient value for the aluminum on the bottom. Now you can just multiply across and divide, and you're going to get there you go. So this is all, you're lucky enough if you get it in moles, which makes it easy. But sometimes it won't be that easy. So what happens if you get mass? Or a unit of grams or something like that. So here's an example. So we have 13.5 grams of aluminum react with hydrogen chloride. So In this case, we're going to be finding, I guess, hydrogen chloride. Well, actually, no. So let's actually try to find the hydrogen gas. That's what we'll do. So in this one, we can't just go straight to mole ratio because we're given it in a unit of grams. So we're going to have to refer to our periodic table and find our molar mass and then work from there. All right, so I know that the molar mass of aluminum is going to be 26.9. That's grams per mole. And so let's write our picket fence just like we normally do with our initial amount. There's our 13.5 grams. And now we're going to put, we want our units to cancel. So our grams has to be on top, which means something grams has to be down here. So we're going to use our molar mass from our aluminum. I'm going to place it down here. And that's 1 mole of aluminum equals that many grams. And so now that our grams are going to cancel, we can go back to our mole ratio like we did in step 1. So learning is our top priority. We have our 3 for our coefficient for our gas and the 2 for our initial. We're trying to get here, so we're going to put our coefficient for the gas on the top. Clarify these are moles. All right, and so now we get 0.75 mole of H2. But normally with these chem problems, if they give it to you in grams, they want it in grams. So let's just go back. So we have our 75 or 0.75 moles of H2. And now we need to use our molar mass again to get back to grams. So in this case, our molar mass for H2 is going to be around 1 gram per mole. But for this one, I'm sorry, for just like the element hydrogen, it's going to be 1. But in this case, because we have a subscript 2, it's going to be 2. So right there. So now we're gonna take our mole value, draw our picket fence, and so now remember, our learning is our top priority. So what we're trying to find, or our units that we're trying to finish on, need to end up in the numerator or in the top. So we're gonna use, we need our moles to cancel. So we're gonna put 1 mole in the bottom, and then our 2 on the top. And this is going to equal 1.5 grams of H2. All right, thank you so much for tuning in. We're going to have a dimensional analysis episode coming out soon, so stay tuned. Thank you.